The cellular architecture was proposed in 1950s by Bullington in 1953 by the frequency economy in mobile radio bands. You mean these are basically the cellular network. So each cell are divided with access point, and according to the access point, there are some wireline connection are there to the core network, and therefore the users are maybe distributed inside the cell. So the cells are basically divided, so the total area is divided by a cellular concept, and definitely uses are going to be increases for a particular region. There may be some problem of the access, and it will the bandwidth will going to be decreases, so control the interference. And another problem is the interference by the fractional spectrum reuse and reduce the power. So these are the basic problem. Even users are very close to the cell area, so in that sense therefore the interference of the nearby cells are another problem at this kind of this cellular architecture. And the most common the sparse deployment of the access point are normally are basically the mobile tower or as well as the rooftop mounting cases. As the cellular area are going to be large, therefore the large amount of power have to be transferred from each of the access point to cover the cellular total cellular area. And it is noted because there are some noise is there to consider under the noise. CNN, that is a bit error rate is EB by a naught is there, so that's why the transmitted power should be high, and again the high power transmission leads to the rising of the temperature and increment of the thermal noise. So therefore it's have some very not efficient even in the large distance due to the attenuations of the according to the Ferris transmission equation. The signal strength are going to be reduces. Moreover, this required a very high power and losses also. So overcome this problem, and the coverage area where to distribute the power equally, the number of access points have to be increases. So the large performance, the variations of the unavoidable. So the large performance variation throughout this total area is unavoidable, because if you have the 4 access point, we can make this the spectral efficiency, that is bits per simple hertz, and the positions are basically most user get mediocre performance. Even if you are going to be increase the number of access point in the same area, still this portion are remain where the signal is not good enough, signal state is not good enough. That's why the SNR is also not good enough. And we know that any kinds of the wireless communications, the thing is that the bit error rate, basically in wireless communication, the bit error rate is basically, we know the bit error rate is basically proportional to 1 by SNR. Bit uh, error rate is proportional to 1 by SNR. Therefore, if the SNR value is going to be increases, SNR signal to noise ratio is one of the major factor. So if my SNR signal to noise ratio is bit per error rate is going to be decreases, bit error rate is also going to be decreases. This is basically in cases of the wireless communications. But in the wireline communication, the bit error rate in the wireline communication is basically, in the wireline communication bit error rate, we know that it is the e to the power of SNR by 2, so it is decaying very slowly. But in cases of the wireline communication, the bit error rate is decaying very fast, as because of the presence of the noise in the environment. So therefore, if in ideal condition, we know the same service can be provided in all, at least in the all the users. So the power spectrum should be in flattened up, at least in like this way. So achieve this with a conventional cellular network where there is some one access point in a particular cell which are which are not overlap with each other. In this condition, the 4G attempt to solve this issue within the cellular paradigm. So how to solve this? Now they in that condition, the cellular with the cooperation clusters are going to be in are going to be there, and there are not overlapping. I mean, they are basically the coordinated and scalable coordinated spatial beamforming technique are basically used there, but a lot of vagal signaling is still not still hard to standardize, yeah, at that condition also. So the massive MIMO, that means one of the technique have to be definitely have to be a number each and every cell, disjoint cell have the more number of antennas rather than the one antenna. We have to increase the number of antennas, so therefore some of the problem have to be solved, but still the interfering problem are still persist. And as well as to solve this problem, massive MIMO on the 5G is attempt to improve the spectral efficiency. Initially, the antennas what are used for the cases I mean to that kinds of the 4G's communications, it was like that the arrays of the antenna and the beam are basically broad beam, so that to coverage the total cell area. But in cases of the massive MIMO, we need some beam forming, which is introduced in 5G. So beam forming, therefore, the array of the antenna, that's array. These are basically linear array. Instead of a linear array, we are going to place this as a planar array. To make this as a planar array, the both the azimuth as well as both in azimuthal direction as well as in cases of the elevation direction, the beam can be steered. And using the steering beam, so interference of the others mobile or the other receivers reduces, as well as the signal to noise ratio is going to be increases. So therefore the massive MIMO system where the number of antenna must be greater than the number of user. So this is the condition is used in cases of massive MIMO transmission, and this massive MIMO kind of transmission are basically strong, become definitely as is a beamforming technique is used here, so therefore it will be a strong and stable condition is achieved. But that the main goal of this to achieve this from the users to give the stronger signal, but the problem still remain. I mean, definitely problem is going to be a little bit solved. The spectrum efficiency is going to be solved, but still some portion are still not solved there. To this condition, we have to be going or we have to going to cell free MIMO structure. So initially the illustrations of the massive MIMO with, with the cellular structure, that is the cellular structure, and therefore with the network, with there is some network, maybe some fiber optic cable or something with the base stations or access point to the users are connected. That this is a wireless communication, and red is a wire communication, and these techniques are again going to be transferred to the cell free massive MIMO. So illustration of massive MIMO with a network base to the cell free, we are coming next is introduction is the cell free massive MIMO. So where there is some CRAN, and that is the server is there. I mean, the cloud computation or the CPU processor is there, where all the access points are connected there. Any kinds of user are coming there, he will going to path to nearby all these communications. They have to make is communication, and which will be the less the less noisy. That means where the least number of the maximum power can be achieved. Least that's here basically used to the link will be established in that cases. So this is totally um, instead of computations is or most is going there, and corresponding load at the central processing unit is going to be increases. And so this is basically cell free network, but the central processing unit are going to there, and the front hall and the access point are basically represent in here. The same as as because it is a MIMO system, therefore here also the number of antennas should be satisfying, uh, definitely the number of users also. So this concept is basically the network centric concept. This type of cellular concept or whatever maybe, it's basically network centric concept. To make its network centric concept to the user centric concept, so that the computations at the central processing unit or the sedans to reduce, so that the all the part of the computations can be taken places in the user centric, that is in access point. The cells are basically overlap, and therefore the each user served by all the access in its vicinity or its in influence, it can be accessed. And to access it, whenever it can access all the vicinity point, therefore this cell is become as a scalable cell free massive MIMO network. And to uh, achieving the probable scalability of the dynamics cooperation, so it is also a dynamic cooperation um, person, and the cell free MIMO is scalable, computationally complexity, that is the computational complexity and the frontal signaling per AP remain finite. So this is the scalability condition. So my complex computational complexity as well as my AP number of AP should be remain finite, even the number of users are going to be increases. That means the stability conditions of my my spectral efficiency I have to be achieved there. So for these cases, time division duplexing techniques at the bag hull channel is going to be is like that way. There is a pilot of TP portions, and the rest of the part are using for the either in uplink or downlink in the TD, because the same spectral are used in TDD time division duplexing techniques. So the proposed solution is each AP is accessed by the one per pilot. That is, the most of the TPR users are one per pilot, and computes the local channel estimates for only those TP users. So I have to estimate these TP which are basically in active condition, or the primary users at a times in the particular network. So computes the beamforming vector. So whenever I compute the beamforming vector of this particular EP, I have to only the active TPs have to be calculated there. So my computational complexity is going to be reduced. Only the complexity is acting in the active users, that is in primarily active. So that my step is there is first, uh, the master TP. I have to define first step is a master TP, any of the closure TP, and then that AP, that access point will be communicate the assigned pilot which are sent by these users, and collect all the nearby APs, so that the least interference happens. Least interference happens means the least amount of I mean the signal to noise ratio is high, or the um, or the power is maximized in that cases, receive power. So this the cluster has been formed. So I can finding out this cluster has been formed according to these nearby tip APs, and therefore my communications are basically how to do it. Now this is basically taken care of generalized likelihood ratio test method. It is a basically binary hypothesis testing where the null hypothesis means and the alternate hypothesis for the signal where the A and S is a basically amplitude of the received signal and this is a signal strength. That is S is known and A is unknown here. So if I make this as likelihood ratio test, that the probability of Y of A for the given hypothesis A is 1 by the probability of, I think so, the probability of Y of H naught is should be greater than gamma or gamma tilde. Means it is, if it is a ml, the gamma tilde will be 1, and therefore this is basically at the same time we are using the cognitive radio technologies where the dynamic spectrum allocation is uses whenever the primary users are not uses that frequency spectrum. So there will definitely all the users are not accessing the all the access point of the all frequency band. So there will be a spectrum hole will be there. That particular spectrum hole is used by dynamically, and therefore the efficiency of that is the my thing, the spectral efficiency is going to be increases significantly in that cases of this techniques of the massing MIMO. And even in the condition of the mobility, whenever this APs are changes, again this likelihood test will be taken place. Likelihood ratio test, actually likelihood test is going testing, and therefore whichever will be the maximize. So the probability of detection of that, we can finding out the probability of detection, and we can make the access point accordingly. So it is a dynamic and computationally efficient, and therefore it's is solutions of these problems. And the maximum likelihood, the estimations of this of the A, that is the amplitude, means high power, maximum high power, or they just in the previous slide what I'm saying. So these things is basically a least square problem. So least square problem, so therefore the A cap, that is the amplitude, is basically S per transpose Y by norm of A square, that is the ML estimation of A, that is maximum likelihood estimation of A. So you can estimating the A value, that is the amplitude value of the A access points, nearby access point, which will be maximum. We can detect that signal according to my pilots will be defined there, and therefore the probability of detections is basically defined the q function, that is a complementary cumulative distribution functions, and the inverse of the probability of false alarm by 2 minus amplitudes, and that is that is the ml estimation of A with the signals, that is a known signal is known the norms of S by the variance, that is random Gaussian noise by AWGN. With this terms again, we can finding out the receiving operating characteristics under this GLRT test, so that we can make the probability which of the detection which signal is stronger enough. And therefore in the cellular network, the philosophy of the interference of the rejections, so we can reject the interference and any kinds of false alarm, etc. By in the cellular network, where the interference only the one observer is survived, that's line of search, and the other are considered as an interference. Where in the cases of the cell-free network, all the points are the three desired signals, and the joint signal decoding is basically taken places. So therefore in the massive MIMO spectral sensing techniques, the model of the MIMO system can be stated as H is a channel matrix, and Y is a receive vectors, and X is a transmitting vectors. So therefore the receive antenna is a receiver antenna, T is a transmitter antenna, and therefore AWG and IID Gaussian noise like this. So we can estimate our channel estimation is like that. And therefore if the signals are IQ signals, we can make the normal distributions of the zero mean in the both cases, and therefore ultimately for the both the hypothesis it becomes as a energy detector, because this is a y norm square. Y norm square means it's an energy detector. Norms of y by norm square is greater than gamma, so it's a hypothesis that the primary user is present, and therefore the next frequency, allocable frequency, we have to go for the when it is in mobility conditions, users are in mobility conditions, therefore the next probable conditions it will be taken care, and it is an adaptive, so that's why next next available frequency band they can chooses, and therefore the MIMO spectrum sensing hypothesis in H1 is a probability of this probability becomes as because they are the IQ signals, therefore we have to this central pi square complementary distributions functions of degree of freedom r is gamma by tp into plus sigma square, that is by 2, definitely by 2 is there by 2 is basically the power, the transmitting power, and we can calculate the probability of detection, and it's definitely so that if the power is going to be increases, that means the denominator value is going to be increases, and which leads to these values are going to be decreases. That's why the cumulative function is value is in the cumulative function at is a complementary cumulative function. That is why the probability of detection is going to be increases. So this is the primary techniques for the MIMO spectrum sensing, and therefore the probability of false alarm, that's in case of interference etc, it can come in there. So we can define it as like this way: gamma by sigma square, that is AWGN under the AWGN, and therefore we can define the gamma is like that, inverse of this Q function, and ultimately we can define the probability of detections, that is the Q square, I mean the central size square distribution Q function of complementary distribution function of these cases in this SNR. Again the SNR value is going to be increases, leads to the increment of the probability, and if it is decreases leads to this conditions. So this is the basic things of the proposed 6G communication, self communication, proposed 6G self communications, and the proposed 6G, where the downlink spectral efficiency can be expressed by the equation, and the channel of the all APC users of the k number of users, I can say of the number of antenna is the L, that is LAP with n number of antennas. So I can set a k users to the L number of there, even if m number of antennas are there, so it should be belong to C to the power ln. So this channel is this, and that channel are definitely have to be make this cluster representation a diagonal matrix, because it is a Eisenvalue decompositions methods. So I have to make the diagonal matrix, and therefore the C is belongs to C to the power ln into ln. So the computation complexity is just ln square is there, and the precoder is used there for the WLL. This is there is basically the row vector by the estimations of the WLIL square, and all I belongs to DL, means the L number of epic point. So this is the thing, I can estimate these values with the value of the variance of these values plus the noise variance of the noise, AWGN normally which is used there, and WAK, that is the precoder, maybe in MR maximum ratio, or it can be SLNR, means the signal to leakage noise ratio. So whatever maybe this last few slides we are coming that SLNR will be better than performance better than the MR techniques are used there. For the numerical evaluation, we can consider some area of the 2 kilometer by 2 kilometer, where the L number of APs, that is 400 APs with the 100k is the basically users. So therefore TP is equal to 10 for users get the orthogonal, and the rest of the across the other are across the other access the after the others things. And therefore if n is equal to 1, I think that is the number of antenna is equal to 1 in this condition. So therefore I can say the spectral efficiency bits per centimeter hertz is coming, the CDF is basically for the mean values. If I say the mean values is MR instead of SLNR is definitely better than LR, MR values, almost double, I can say. Similar way, even the antenna number of antenna is going to be increases, that is n equal to 4. Here also in the mean values, here it is near about 2 in cases of MR, but in SLNR it is almost equal to 4. So the double the performance is there. So we can say the SLNR is precoder is better in these cases of MIMO, particularly is better than MR. And the why it is so, because we can say if m equal to, suppose for simplicity we can consider n equal to m equal to k equal to 1. In this condition we can estimate the channel gain is power is basically concentrated within this condition, rather than the MR it is decaying like that way. So we have more efficient that is spectral efficiency high, spectral efficiency high rather than SLNR spectral efficiency high rather than the MR techniques. And similar ways in cases of the uplink also the realized zero forcing receiver are going to use it, which is a counterpart of the SLNR, and is giving us the spectral efficiency better than this is this is spectral efficiency of this is better than that of the previously used MR techniques. Even here also you can find almost the double the things. Even in this condition you can double the things. So both the cases we can conclude it, the things. So as a summary, a new look at the cell-free massive MIMO techniques. The original cell-free massive MIMO is not scalable, but we can address that using the dynamic cooperation cluster to make the massive MIMO as a scalable, and that's have been published in the papers here. Given the reference here. The new contributions, what we can finding out, that's the first is the access protocols for the cluster formations. That's we can find for this study. Even the general spectral efficiency, that's also we can say, and as well as the SLNR or the zero forcing for realized zero forcing is out far from over the MR. So these are we can observe from here. But the thing is that the problem still remain that the smart distribution of power control utilization structure in frontal, because all these techniques are quite I mean the number of antennas is going to be increases, computations are going to be increases, etc. So it is most costly enough. So make it as a more efficient and achieve this type of power techniques where still some portions are not SNR is not good, or power density per spectrum is not high enough, or data rate is not high enough to coming out here. The one of the solutions toward the 6G cell, still it is in proposed stage, that is the cell free massive MIMO and radio stripe. That is the thing, that is basically traveling wave type of antennas where the cable are there, because in the things all the positions data in our coverage area not required the same amount of data rate. Some portions like galleries, cinema halls, or some gathering, local cultural gathering, stadium, etc., any kind of railway stations or airport where the people are basically gather more, there we can make some cable and that cable may be invisible also, and and the number of antenna can be mixed on the each and every cable, so that the number of antennas are going to be increases, and the upform perform, that is the spectral efficiency are going to be increases, and the flats power spectrum can be achieved in these cases. Even the cases if the size of the antenna is one of the concern. So if you consider the higher the frequency that are going to be increased, definitely antenna size are going to be decreases, because we know that the antenna size are basically near about this is a lambda by 2, but lambda z by 2 we can say the printed antennas. So the thing is that whenever the higher the frequency means the millimeter wave, terahertz wave communication, if you are going there, therefore the efficiency of the antenna and the coverage area are also going to be decreases. And another thing is that the combinations of this antenna basically makes an arrays. So there are some position of the peak position are also there. That's non-linearity of in the receiver amplifier space is another problem. So we can stabilize it over this channels cutoff. This was another thing, and this is another I mean the new area of research is that that is RIS, intelligence surface, reflecting intelligence surface. In microwave it is also known as the metamaterials or the metasurface, sometimes a holographic beamformer. Different names are there, and where the concept is that this is not an antenna at all, but here when the electromagnetic wave are falling there, they have the capability, means as it's a metal containing, so the tangential component and the normal component, the tangential component that flats on the metal surface, and the normal component that bounce back to the angle, and changing the impedance of the surface, we can steer the beam where the pilots are basically less, I mean these users sending the pilots in which direction it have to be steered. So there will be some mapping techniques will in backend of this meta surface, and this is a holographic meta surface based orthogonally discrete unit cell, flexible beam formation, and the polarization control. I mean, in the electronic communication, the polarizations is also one of the things. Until otherwise we cannot, if the polarization mismatch, the power losses will be also there. So all the things can be controlled by the units meta cell, and they are connected via this pin diode. So according to the biasing techniques, their impedance are going to be changes. So impedance matrix are going to be changes. As the impedance matrix is going to be changes, the propagations of the surface current on the antenna are also going to be changes, and therefore we can have the real part and the imaginary part of the impedance are changing, make uh, I mean the make the incident ray and the reflected ray angle are going to be differ from that cases. So I can steer the beam in the maximize the steer the beam and the maximize in a particular directions where my user is there. So in access point, that's not this RIS surface which is acting as an access point, dummy version of the access point, can be steered the beam and giving me the interference free communications with this particular users. So the beam can be steered in that way. So this is an advantageous conditions, and we can say that RIS involved the selfie MIMO system have definitely the throughput is high for the same CDF, that is that is high, that is almost, yeah, I can say it is 27 28, rather than the selfie, where the selfie is fallen here in both the cases, in the uplink or as well as in the downlink. So RIS, incorporation of the RIS will giving the much more better performance over the things is there. So in this kind of this proposed 6G communication, it is becomes such a reliable, it is a flexible, it is easy to install, in some cases it is invisible also, and it is designed scalability and the reduced cost, and also it has a few components also, rather than have to be going the huge number of antennas or etc, active devices or etc. So these are the things and advantages of this thing, and therefore the efficiency, electrical efficiency and the hardware efficiency in all the cases, the cell-free MIMO is very efficient, and the the number of antennas are almost in the cellular cases, and the cell-free cases are almost the same, and the spectral efficiency is going to be increased. So this is one of the advantage and the cases, and definitely peak data rate corresponding this selfie massive MIMO giving is from the 5G to 6G. It will be proposed that 1 TB per second, maybe even the data rate is 1 GB per second, so it are going to be increases. Even one of the discredit is definitely due to the mobility of the users, or scanning with the likelihood test, whenever which access point is giving the better conditions, so there are some latency are going to be increases, and as and it's we know that it's a TD techniques, so that latency is one of the problems is there. Until otherwise, the 6G, the most advantageous thing is the data rate. Data transfer rate is very high, so high speed data transfer can be possible in cases of the cell-free MIMO techniques. So these are the references, and thank you very much.